Okay, so we have a lecture today on Python. This is the first lecture. So we will discuss the basic concepts of Python. We will just be understanding the basics, core concepts that every programming language has. So we will discussing about real names, rules, and we will discuss about data types that are primitive data types. We will discuss about the typecasting and how we can input and output in Python. So we will also look at the aspects of outputting, that's printing and formatting. So first for the setup, so you can use Python in a variety of ways. So one of the very popular ways is to install Python directly from official website, and like any version that's suitable for your operating system. So any recent version will work, any stable version would work. So after you have installed, you have to add the path to the environment variable. One other way is to use VS Code. So you can download VS Code and install a Python extension. And for interpreter, we can select Python interpreter from the command palette. So you can run Python directly in Google Colab. That's what actually you're seeing right now. It's a local version that's running on VS Code, so you can also get a version of extension of Jupyter Notebook in your VS Code. So variables, rules, and names. So a variable is a name that refers to a value in memory. So Python is dynamically typed. So whenever you want some value to be stored in the memory, you use a variable. Python is a dynamically typed language, so you don't have to just to like list. Don't have to write the type at the beginning. So it decides the runtime. It decides the variable data type on runtime based on whatever value you are assigning the variable to. So generally, the rule goes that you have to always keep the value to assign on the right side and the variable on the left side. So some naming conventions. So the valid way to name a variable is to start with a letter or underscore, and it can contain digits, letters, and underscore. Names are also case sensitive. So by case sensitive, it means a variable with lowercase n name and a variable with uppercase n name will have will always have different memories. So they will not be same variables. So invalid way to start, like a variable name would be to start with a digit or start with @ dash or hash. So you uses so we cannot use the keywords like the class if true. And here are the examples of the variables that we can create. So we have first variable x that we have created. That's a variable that has value 10 in it. Next we have a variable that has a string value in it. So that will be a string variable. Third, we have a price variable, and we have placed 99.5, which will be a floating type variable. So if we run this, so you can see the output. Okay, so for the best practices, it's always recommended to use meaningful variables. We use full names. So just for example, like total price, instead of writing TP, it's better to write total price. And we in Python we prefer names with underscore and with lowercase underscores. So to avoid confusion, single letter variables are not recommended. Here's an example in which we are assigning multiple variables at a time. So previously you saw an example, we were assigning one variable at a time, but we can have multiple assignments. So in this, we have three variables, A, B, and C, and we are assigning 1, 2, and 3 values, integer values respectively. And then we have a print statement after that. There's another statement that like creates 3 variables, P, Q, R, and all 3 variables are assigned 0. So this expression works like creating R and assigning 0 to it. Then value of r is 0, that's assigned to q, and that value is assigned to the p variable. So finally, let's see what are the types we are dealing with. The integer types is generally positive or negative, and zero also is integer types. We also have floating data types, which are like decimal point based number. They are negative and positive both. So we have strings. Strings are first string types, and a last type that's very popular in logic building is boolean type, which can be either true or false. So typecasting, like if you want to convert one type into another, here's an example. So currently we have variable a, and we can see that variable a has string 10. It's not integer 10, it's string 10. So if we want to convert it into an integer, what we can do is write int brackets and close the variable that you want to convert. So by doing this, this will convert this variable into an integer variable. Same thing you can do with float, and this will be converted to float. So in order to test that if our type conversion worked, we have taken those variables and we are printing their types. So in Python we can print type by just writing type, and the variable inside it will print the type. So we are printing the type of all the variables. So this will come out to string type, and so will this. But when you print, when this statement executes, this will come down to an integer, and this will come down to float. Okay, for input and output, so like very basic, we have a print statement that prints. So this print statements, you can write values in it, you can write multiple values in it, you can write comma separated values. So let's see how we can print. So here are the examples. So they are writing hello, will print directly hello with an endl new line. This will print A, B, and C in a single line, and endl will be added after that. So after that, this is a line that will separate each with a dash. And finally, we have a print statement that like tells that in like don't end the statement with end statement with a full stop. And finally, we have a hello world statement that will only print world. So for input, so input statement is also very basic. You just need to write the input keyword with the brackets and write the prompt that you need to ask or what you want to input. And once you have entered the input, you can see the resultant output. Thank you. Input keyword with the brackets and write the prompt that you need to ask what you want to input. And once you have entered the input, you can see the resultant output. Thank you. Okay, so today we will be discussing if, else if, and elif statement. So if and else are very common programming control flow statements which are used to change the flow of the program. So for our example, we are taking an input from a user and checking if a number is positive or negative. So what we did is we took the input and we converted into int. And in the next line, we have an if statement that checks if the number is greater than 0, it prints positive, and if and the else part runs when this expression is false. So whenever this expression is false, if the number is not greater than 0, the else part will be executed and it will display 0 or negative. Now let's run it and see how it works. So if I enter 5, so we can see the positive, and if we enter any negative number or 0, it will give us 0 or negative. Okay, so this is the basic example of if else. And if we want to use multiple if statements that are related to each other, they are working on a single variable, and we want to find out what value we have to take, or what path we have to choose. For that, we can use else if statements. In Python, we name it elif. So here we have a variable marks in which we are taking input of mark from 0 to 100. And in this code, a piece of code, we are actually trying to get the grade based on the marks. So for example, if the grade is greater than or equal to 90, it gives us A. It assigns grade, the variable grade A. And else if marks are greater than or equal to 75, it assigns it B. And else if marks are greater than or equal to 60, it assigns C. So finally, we have else. So if all of these conditions don't work, else part will be executed and the grade will be assigned fail value. Okay, another very important thing, if we enter marks greater than or equals to 90, only this part will execute. None of these other parts will execute. And same goes for any elif. Let's say if marks are greater than or equals to like less than 90 and greater than or equals to 75, this condition will become true and only this part will execute. Nothing after it. Okay, so let's run it and check. Okay, grade A. And if we enter 95, we get this. And let's say if we enter 65, so we get C grade. Anything other than that, like even 55, we get fail grade. Okay, so next we have an example of nested if. Okay, this involves an example where we need to check multiple conditions. We could use it using and as well, but just in case we have different outcomes. For example, in this example, we have two variables that we are going to take input, which is age and has tickets. So if a person having age greater than or equals to 0, it will enter into the first if, and here we have to evaluate if that person has a ticket or not. If he has a ticket, then we can move towards like print, you can enter, or we can move towards this alternate path, which is print ticket required. And just in case if the person's age is not greater than or equal to 18, the else part will execute and it will print you must be 18 plus. So in this example, we have used a nested if. It's an if within an if, and it works like this. So if we run it, and it's asking for the age. Let's say if I enter the age 19, and I enter ticket yes, so it will print you can enter. And let's say if I enter age 19 and enter input no, it will ask that your ticket is required. And just in case if I enter age less than 18, it will straight away take me towards the end. Okay. And if I enter this, no, so it doesn't go through the inside if statement. That's it for now. For the next lecture, we will discuss loop. Okay, welcome to lecture 2 of Python. So today we will be discussing about the arithmetic, comparison, and logical operators. And we will also be covering if, else, else if, and we'll also be covering loops, the common loops, the for, and the while loop. So for today, we have arithmetic operators. For arithmetic operators, we have following. One of the very popular arithmetic operators, the plus, minus, multiplication, and division. So these are commonly found in almost all programming languages, and they are as is. So like if we add two digits, we just need to use the plus operator here. And if we need to add like subtract something, we need to use the subtraction operator. For multiplication, we have the multiplication, and for division, we have this slash. So these operators, one of these operators is also very common, the modulus operator. We use it to find the remainder. And these are two new operators, this double division symbol and double multiplication symbol. So they both are divisions, but the single division gives us a floating point answer. But double division sign gives us an integer value and gives the floor division, meaning it just drops the decimal part and gives you only the integer part. So next we have two asterisks. So single asterisk is for multiplication. If we like put two asterisks between two numbers, we get the power. So for example, here we have 2 to the power 3, which is 8. Okay, so important points, like the modulus always returns the remainder, and like the simple division sign returns float, and double division sign results in a float value, the integer value of the division. So here's an example in which we can see all in action, and we can see the output. So we have two variables, 10 and 3 in A and B, and we summed, we did all the operations, and we have the answers here. So for example, if we did the division of 10 divided by 3, we get 3.33, and that's a very long decimal number. But if we just keep it to the floor by using two division symbols, we get only single integer answer with no decimal values. Similarly, if we take power of 10, which is the value in A, with 3, we multiply 10 3 times with itself, and we get 1,000. And rest of them are exactly the same. So 3 into 10 is 30. 10 minus 3 is 7, and 10 plus 3 is 13. Okay. Next we have operator precedence. So the precedence means, well, if you have a mathematical expression, what will be evaluated first? So in this case we have brackets, then the power symbol, multiplication, division, and floor division, and modulus has same precedence, and same goes for plus and minus. So precedence goes this way. So the first will be evaluated, well, the brackets will be evaluated first, then a double asterisk, the power, and then so on. So here is an example that shows how it works. So we have x, which is equals to 5 plus 2 into 3. So here, according to precedence, we know that plus has a lower precedence, so we will have a multiplication first, which will result in 6, and 6 plus 5 is 11, and that's the answer in the x, you can see. But if we place brackets, so brackets will be evaluated first. So 5 plus 2 will be evaluated first, which is 7, and 7 will be multiplied with 3, which will give us 21. Okay, so now on to the application of modulus operator. So for modulus operator, we can use it to find if a number is even or odd. We have a number, variable, num, in which we are taking an input, and if we take mod with 2, which means that number is completely divisible by 2 and leaves remainder 0, then it means the number is even. Else, the number is odd. On to the comparison operators. So comparison operators are return true or false. For example, if we have this symbol, there is a difference between single equals to and double equals to. This is an assignment operator that assigns values to the variables, but this is a comparison operator which compares two values. So double equals to means we are checking if the two values are equal or not. And there is not equals to, this is an exclamation mark followed by an equal to symbol, and greater than, lesser than, and lesser than, equals to, and greater than equals to are mentioned as well. So here we have an example. So we have again two now variables a and b. If a and b are equals, so it should display true. If a and b are not equal, it should display true as false. So in our case, we have 10 and 7, so they are not equal. So this will probably give us false. It should give us false. And the number, the expression under it is just not equals to, which is true because they are not equals to each other. So this is a true value. When a is greater than b, yes, it is greater than b. So 10 is greater than 7. So this should be true as well. And followed by if a is lesser than b, so that's not true. 10 is not lesser than 7. So this would be false. False if a is greater than equals to b. It is 10 if 10 is greater than equals to 7. So this should be true because it's greater but not equals to. And finally, we have again a false statement because 7 is like not 7. Actually, this statement is true because it's not true because 7 is not lesser than or equals to, 10 is not lesser than equals to 7. So we can use these operators to compare strings as well. So we have apple, two strings. So what do they have? They are both equals. So they will display true. So now we have like different strings. It's apple and banana, and we can now compare their ASCIIs. So the first character is A. So A is not smaller than B. So this will turn out to be false. And finally, we have Z is lesser than A. So Z is uppercase Z and A is lowercase a. Even though Z comes like later on, but in the ASCII value, Z has a lower ASCII than lowercase a. So in this case, this would be true. So that's it for now. We will continue with logical operators in the next video. Alright, for today's lesson we will discuss loops. For loops, we have first for loop. So Python has both for and while loops. For loop, we have to look at the function. That's the range function first. So range has three variations in it. So the first variation is with a single parameter. The other variation is with two parameter. So the first variation will start from 0 and end before the value written here. So the second range function has a start value. It will start from where we want to start and will stop before this value. Also, we have a step function, step variable in the range function. So we can start from this point, end at this point, and this is the jump that we take. So traditionally we take one jump, like if we have this function, for example, if we write the range 5 here, so what it will do, it will start from 0 and come up till 5. So this is a for loop. In for loop we have this syntax. This is for, that is I, the iterator, and the range. So this range function gives us values from 0 to 4. So what it does, for loop takes each value generated by range and runs it one by one and prints the value of I, and prints the value of I from 0 to 4. Similarly, we have a range function with two parameters. The one is the starting variable and the other one is the ending. So we can start from 2 and we will end before 6. So it will have a range from 2 to 5. Similarly, we have a range function that takes three parameters. First parameter is the where we want to start and where we want to end, and the step size or the step is in negative. So we will start from 10 and we will go up till 0, and we will actually stop before 0 and we will do -1 at each step. So for this, we started at 10, we subtracted -2 each time the loop iterated, and we got the displayed value of 8, 10, 8, 6, 4, and 2. So the common task we can do is like take the input from the user, and here we have taken input from the user. We have added it to range. So we want our range to start from 1 and go up till the value of n. So here you can see where you have added +1. The +1 is added just to add value to the range. This will go up till 5. So after printing, we get 1, 2, 3, 4, 5. Next, we have again a function. In this, we have adding values 1 to n, and we are totaling them, summing them up. And when we sum them up, we get the total values from 0 to 1 to that number. So for example, we have n, and we take an input, and we have a total variable. We assign 0 to it. We make a for loop. We start from 1 and we go till that number, and we add the variable to total every time. This gives us the value that we desire. So if we run this program, if we enter 5, so it will add values 1, 2, 3, 4, and 5. If we sum 1, 2, 3, 4, 5, we get 15. So that's it for the for loop. For the next time, we will discuss the while loop. So in this lesson, we will discuss while loop. So while loop is a very popular loop in all of the programming languages. So this loop has no iterator in itself. We have to iterate the loop ourselves. So here's a classical example of while loop that prints values from 1 to a number. Like here it is 5. So in this example, we have taken an iterator value I is assigned 1, and we are checking a condition where I is less than equals to 5, and we print the value of I, and we increment 1 in I. So when the loop starts, we have I is equals to 1, and we print the value of 1. Next time it's incremented to 2, and then we check again. So this time 2 is less than equals to 5, and this continues until this condition becomes false. So if we run this program, we can see, and we can see the printed values from 1 to 5. So while loop is most commonly used for input validation. So here's an application how we can use it for input validation. So here we have a password, and in password we are entering password variable. We are entering a password. We are asking a user to enter a password with minimum 6 characters, and in loop we are checking if the length of the password. Length is a built-in function that gives us the length of a string, and if the length of the string is lesser than 6, then we have to print the password is too short, try again, and we have to input again until the condition becomes false, and we come out of the loop, and then we can say the password is correct or password is safe. So now let's run it. Let's say if I enter something that Python, so it's a 6 character a password, and it's acceptable. So if I enter anything less than 6, so it will ask again, okay, until I enter something that's greater than or equals to 6. Okay, so next we have break and continue statements. So in an infinite loop, sometimes we need to eliminate or terminate the loop. So in some cases we need to like move on, we need to skip a certain step in a loop. So for that reason we use break and continue statement. So currently we have an application of these two statements. So for example, there is a while true loop. We are taking input, and we are actually checking if the user has entered exit or not. if a user has entered exit, so we can break. What break does is what it does is takes it out of the loop. So we'll break the loop, we'll come out, and if there are rest of the lines in the code, those will be executed. So for now, what we do, we are taking input, and there are like two more functions added at the end. There is a strip function and a lower function. What strip does, it removes all the spaces or handles or line breaks. So and the lower, it converts any uppercase character into lowercase characters. So when we enter the input, we check if the text is equals to exit, we print stop, and we break, and we come out of the loop. If it's not true, we haven't entered exit, it will print that you have typed this text, and it will continue. Let's see it in action. So let's say if I enter you, so it will say you have typed you, and it's saying enter exit to stop. So let's say if I enter exit, it will stop. So this is what break does. So break can like break you out of the loop when you don't need the loop to further work. Next, we have an application of continue. So this is when you skip a step and you like continue with the loop. So here we have an n variable in which we are taking an integer input. We're actually typecasting the input as well. We have two more integer variables, count and total, and there's a loop that's checking where count is less than n. So until this statement is true, this loop will continue and work. We are also entering an input. We are asking an input from the user, and we are like incrementing each time we enter the loop, and we are continuously working on it. And if x is lesser than 0, the input we are entering here now, what we will do, we are skipping the negative number. We will not be adding negative number, and we will be adding it to total. So every time we enter a negative number, we will skip. So in order to skip, we have placed a condition and placed a continue statement. Whenever we enter a negative number, it will not be added to total, and we will skip this step. So for example, so let's say we want to enter 5, and let's enter 1, 3, 2, 4, and if I enter -9, so you can see that it has summed these numbers 1, 3, 2, and 4, which sums up to 10, but it has skipped -9. So due to this reason, we need to use continue statement. What it does, it has skipped the total summing process in the value. So -9 was not added to the total. So this way we can use continue statement. So next we have homework mini assignments. So we will discuss it in the next lesson. Thank you for now. For mini programs, we have a loop-based calculator. So this is a calculator that asks users to enter numbers and what operation to perform between them. And once they have entered this information, what it does, it takes those inputs and does the calculation based on the operator entered, and it starts again, like it's again asks for numbers to do some operation on. So you can pause the video and try it yourself. So if you have tried it, so this is one way to do it. So what we have done, we have created a while true loop, and in this program we have asked the user to enter the choice of from 1 to 6. Like 1 is for add, 2 subtract, 3 multiply, 4 divide, 5 power, and 6 modulo. And in case user enters exit, the program quits. So here we are entering the choice from the user. User is entering choice 1 to 6 or exit. So first we are checking if the choice is exit. We can say that exiting calculator and goodbye, and that's the end of our program. The break statement works, and we come out of this infinite loop. If the choice does not exist and it's between 1 and 6, so what we do is we create an if, and we see if the choice is in between them. We do the operation. If the choice is not in between, we can say that we have an invalid input, and we will input again. So whole menu will be displayed again, and we'll input again. So just in case the input is wrong, we will have to enter the choice again. So if the input is between 1 and 6, what we will do, we will take two numbers, and there's a try catch block. We will like learn these in the future lessons, but for now you can understand, if you have programming background, this is exception handling. This is just in case if a user enters anything other than floating point values, this will be handled. So like we are entering two values in num1 and num2, and now we are matching the choice. So if the choice is 1, what we will do, we will sum these two numbers and print them. And if it's 2, it's the difference. 3 is multiply, and 4 is divide. And here we have also placed as divide by 0 check, because if the second number is 0, we cannot divide it. So this works that way as well. And finally, we have 5. That's for the power, and 6 is for the modulo. And modulo and divide, we have checked if the denominator is 0 or not. We cannot divide by 0, so that's a mathematical error. So we are avoiding that by using if statements. So if you understand this, let's run it and see how it works. So first we can try exit and see if the exit works. Yeah, that's working, and we are out of the infinite while loop. The second is while we can enter the values from 1, 2, and 6. If we enter 1, what will happen? We will be asked to enter a number. The first number, let's say we enter 2. Second, we enter 3, and we have the answer. That's 5.0. You can see here, and again we are prompted with the menu for values to enter. So here we can enter any values. For example, now if I want to, let's say, try to divide, and for that I have to enter 4. So it will again ask for a number. If I enter 14 and then 2, so we can see the answer here. That's the answer. That's how it works. Okay, that's for the question having a calculator that is loop based, and it works forever. So let's exit this for now and look at the second question. So it's a guess check game. In this, you have to generate a random number and ask user to guess it. So if the user guesses it higher, so you have to tell the user you have guessed a higher number than what actually the number is. Or if the user guesses lower, you have to tell user you have guessed a lower number. So for example, let's say the number the user has to guess is 5. The user enters 7. The program says you have gone higher. So if the user enters 3, the program must say that you have gone lower. So this is a game that you have to develop. You can pause pause the video and try to do it yourself, and I will share the solution afterwards. So for the solution, we have imported a library that's a random library. This is used to generate random numbers. For this example, we are generating random numbers from 1 to 10, and we have also a variable of attempts. We are assigning 0 for now. So in this program, we are printing a statement that says the number is between 1 to 10, and you have to guess it. So first, again, there's an exception handling block. We will discuss in future lectures. So first, we will have a guess variable in which we are taking an input, an integer input. And what we do every time the user enters the guess, we increase the attempt by 1 as it's increasing the attempts. And if the guess score is is greater than the secret number that we want the user to guess, we can say, if the guess number is smaller than the secret number we are going to guess, we can say too low, try again. And we have an else if, in which if the guess we have done, the user has guessed the number that's higher than the actual secret number, we can say too high, and we can say try again. So in other case, we might have guessed correctly, and we get congratulations, and we get the secret number and the number of attempts that we took to guess the number. And once we have guessed it, we break. We come out of this infinite for loop. This for while true means it's an infinite for loop, and that's the termination of the while loop. So hope you understand it. So next lecture we will be discussing about the data structures, some of the very common data structure in Python. So see you then. Bye. So for lecture one, we have a few programming practice questions. So here we have a question in which we want to design a program that calculates the bill, and what it takes as an input is bill amount, number of people, tax percentage as input, and it should calculate total bill after, and it should also give us information about what each person has to pay. So here's the coded complete example. We are taking inputs. So the first thing is we need to determine what inputs do we need. We have total bill amount, number of people, tax percentage as input, and that's what we have done. We have taken 3 inputs here, and we have converted them into their respective data types. We know that whatever we take input in Python is in string, so we have to typecast it into whatever data type we want to use. Once we are done with that, we can calculate the tax amount. So what we do is we multiply total bill amount and tax percentage and divide it by 100. That gives us the total tax amount. So after that, we can calculate total bill after tax, which is the total bill amount that we calculated here and convert it into float, and we can add the tax amount in it. So here we had the total bill. Now we want to know the split. Single person has to pay. So amount per person would be total bill after tax divided by number of people. So, and the following lines are just print statements of all the things that we have calculated. The total bill amount in float, the number of people, the tax percentage, tax amount, and total bill after tax. So that's what we have. Now if we run it and try to execute it, let's say we enter total bill amount 100, and number of people we enter 5, and let's add a 25% tax. So the total bill amount was 100, number of people were 5, the total tax percentage was 25%, we entered here, and tax amount was 25. The total bill after tax was 125, and per person bill would be we can print it right now. Print. Okay. Amount per person, and we can just type amount per person. That's it. So if we run it again, let's enter 100. Let's enter 5, 25%, and that's what we get. Okay, the next question is about salary breakdown system. So we have to develop a system in which we take input monthly salary, tax percentage, bonus amount, and that's the total input that we take. And we must calculate the tax deducted, salary after tax, and final monthly salary after adding bonus. So even though we seem like we have only two inputs, actually we have three. We have to enter the bonus as well. So we have three inputs. We take it from user, then we convert into respective data types. Here we are going for all three floating point values. Next, we have to calculate the tax. It's the same we calculated the tax before, and after tax we deduct it from the actual salary, the monthly salary, and then we calculate the final salary by adding bonus to it that we input from the user here. And finally, we have this output statements that show what will be. So let's say we take 100 salary and we have a tax percentage, let's say 20%, and let's take bonus amount to be 10. So we seem to have an error, and that error is bonus underscore float. So we have to use the value that's being converted. So let's run it again. Monthly salary is 100. Tax percentage is, let's say, 20. Bonus amount is 10. So we can see that after tax percentage, we are left with 80, and after adding the bonus, which was 10, we get to 90. Okay, we have another example, that is digital wallet transaction. In this, we are taking current wallet balance, purchase amount, and cashback percentage as input. So the program has to calculate. What the program needs to output is to cashback earned and give us the final balance in the wallet. So again, we have different inputs. The two inputs we took, those are in float. We converted them directly here, and after that we converted. We calculated the cashback, the percentage the same we calculated before, and once we have done that, we actually take the new balance. We subtract the purchase amount because we have subtracted that, and we have to add the cashback into the new balance amount, and we have just printed two values, cashback and new balance. Now if you run it, let's say our wallet had 100 and the purchase amount was, let's say, 30, and the cashback was 50. So we can see that the cashback, that it was 50% cashback, so 30 had 50%, 15, which we added to our balance, then that's a new balance. Okay. Finally, we have an example of electricity bill calculator. So it's a very simple example. It takes different inputs. So first we need to take inputs for the units consumed, and we have to input cost as per unit. So what's the cost per unit price? We also have to apply 5% surcharge to the bill amount. So we have three inputs here, and finally we have to display the amount, the final bill amount. So we took units consumed here, and we took cost per unit. Okay, so we didn't have to take the surcharge because as it was 5%, we can directly multiply the total bill with it. So we multiplied units consumed with cost per unit, which gave us the total bill, and then we added surcharge by multiplying it by 0.05, the total bill. We get the surcharge value, we add it to total bill, and now we can see the total bill. We can see the total output, in which we can see units consumed, cost per unit, total bill, surcharge, and the final bill. Now if we run it, let's say we consume 100 units, and each unit costs around 36. So in total, we will have a bill amount of 3,780 after 180 rupees surcharge. So that's it for now. Now for the next video, we will discuss about if else and loops in in Python. Thank you. Bye. Okay, let's start the next topic in Python, that is Python strings. So we will first discuss how we can slice Python strings. So slicing is a method that in which we try to extract subpart or substring of a larger string. So given a string, we have let's say we have a string Python, and if we want to like get some part of it, we can do it using slicing. So slicing is done with different ways. So before we go into slicing, we have to discuss how strings are indexed. So indices are where the characters are placed in a string. So if we see this string Python, in this we have 0 index, that is the on which we have p, where index 1 we have y on it, and so on, so forth. So if we are discussing in negative index count, so that's how it's presented here. So it starts at the end, and -1 represents the last character of the string, and the size of the string represents the first character. Negative sign with the size of the string represents the first character of the string. Okay, so this is a slicing syntax. We have a text. We have to tell where we have to start the slicing and where we have to stop. And the step size tells us how much jumps we need to take. So how many characters we need to move along. So this will all become clear with an example. So you can also omit like any of these parameters, and if you omit start, it will start from the beginning. If you omit stop, it goes to the end. And if you don't use the step size, it will consider step size as 1. So we have a string Python, and we are printing it here. And in the next step, we are printing its characters. So if we print S0, we get P, because P is at the 0th index of the string. And if we print 3, so it prints H, because this is the character number 1, this is character number 2, and this is the character at index 3. That's why we see 3 on 3 index, we see H. And similarly with -1, as we discussed, -1 represents the last character of the string, and that's what we have like printed out. Similarly, if we go -2, so it considers the second last, and that's what we have here. On to the next one, that's Python. That's more about slicing. We have a string now, Python programming, and we are applying now different slicing methods on it. So first we print the original, and in next we give us the start and the end of the string. So for example, in Python programming, we can start from here, and this is the 5th index. And generally, when we print something, we have to mention where we have to stop. So this would be 5. Why? Because this is at index 0, y is at 1, and so on, and is at 5th index. So our 6th index is this space that we have. So it will stop before that, and it will just print Python. So similarly, if we go from 7 to 18, so we will skip this space. We'll start with this character as it is at 7th position, 7th index, and we'll start from here and we'll print the whole string. Okay. Similarly, here we have missed the initial, the start value, and we have just mentioned the end value, and this also yields us the same result if we enter the initial value. So that's what we discussed here, that if you don't mention the start parameter, it will automatically begin from the start. So that's what's done here. So we missed the start parameter and it start from the beginning. Next, we have another in which we have missed the end parameter, and it goes straight towards the end. You can see that programming is printed completely. And finally, If we miss both start and the end parameter, it prints the whole string. So next we can move towards how step count works. So we have another string that's A, B, C, D, E, F, G. So in this we have said that print the whole string because we haven't mentioned start or the end, and we have said that we take a step size of 2. So what it does, before when the step size was 1 by default, it was moving 1 characters only. Now it will be moving 2 characters. So it will start from A and it will move 2 characters and come to C. And it will come to C and again move 2 characters C, D, and it will print E. And then again it will move 2 characters F and G and it will print G. So that's what we have output here. Another modification is that we don't start from the character A from the 0 index. We start from the 1 index, and again the end index is not mentioned, so we are going towards the end. And the step size here is 2, so we will start from here B. We will move 2 characters. We will print D, and then we will move 2 characters E, and we will print F. And we could move 2 characters, but we have only 1 character left in our string, so that will be it. So we'll only have B, D, F as the output. So finally, we are printing everything with the negative step size. So what it will do, it will start from the end and it will reverse the string. So very important interview question. So how you can reverse the string in Python, and that's the solution right here. You can print the string and just enter negative 1 as the step size. So some more interview friendly questions. So the stop index is not included, as I have just discussed before. So if you enter 6 index, which is space, was not included. It only stopped till n. So stop index is never included when it comes to slicing. And another thing is that even though your string length is quite small, you could enter a very large number and it's safe, and it just ends when your string ends. It doesn't like goes out of bound or something. Another very important thing is strings are immutable. So what is immutable? You cannot change the characters directly. So let's focus on this example first, which is entering the end value or stop value, a very large value. So for example, we can see we have a string hello. It has a character length of 5, but we entered the end value as 100, which is way more than what we actually have. So if we run it, it runs it without an error. It stops when the characters end in the string. Similarly, if we try to like change a single character, okay, so currently this line is commented, and if we uncomment it and try to run it, it will give an error. So let's see the error. So it's okay. Let's see the error. Okay, so it says that it's a type error. And what kind of error is that? It says that you are assigning something in the string, you are changing the original string, and that's not possible. Why it's not possible? Because string doesn't support item assignment, so you cannot change the string within it. So we have to like create a new string and copy or change whatever we want, and we can assign that back to s. So that's what we can do. So how we can do it, there are like string methods which we will discuss in the next video. Thanks for watching. We will see what happens when we use string methods in the next video. So welcome to the Python course. So we are going to discuss Python string methods. So there are many Python string methods that exist, and some of them are very common methods, and they are used on the regular basis. And these are mentioned right here. So we'll discuss them, how they work, and we will try them with different examples. So first we have lower upper title. So let's look at these and let's see how they work. So we have a Python string. It's Python is fun, and you can see there are some uppercase and lowercase characters in this string, and we have like different methods that we have applied. So what upper does is converts all the characters into uppercase, and what lower does is it converts every character into lowercase. So this is the original string. Python is fun. You can see there are like upper and some lower characters in this string, and after passing through the lower function, everything is printed in lowercase. So, and after passing it through the upper, everything is displayed in the uppercase. And we have another function that's title. What title does is it makes every word, the first character of every word, in uppercase. So originally we saw that is I was in lowercase, F was in uppercase, but what it does is makes every other character in lowercase except for the characters that are appearing on the first or the initial character of every word. Okay. Next we have where we have another string which we are going to try and check the different methods of strip. So what is a strip function? Strip function removes extra spaces. So we have a string that has some spaces at the beginning and some spaces at the end. And what we are going to do is use different functions and see their output. So if we print the the variable, the original string, it prints with all the spaces, and that's how it prints. And if we use strip, what strip does, it removes all the spaces from the beginning at the end. Both end and beginning spaces are removed. And if we use lstrip, it just removes the spaces from the left side, from the beginning. And if we use the rstrip, that stands for the right strip. So whatever is on the right side, it strips. So you can see that in lstrip, the spaces on the left were removed, and in the rstrip, the spaces on the right were removed. Okay, so very important string methods: find, replace, and count. So let's say we have a string. I love Python. Python is powerful. So we have a replace function. What it does, it finds that or finds a string and replaces it with whatever string you want. So originally we have a string the name having Python multiple times, 2 times actually, and we want to replace it with Java. So what we do, we pass it through a function s.replace, and we want to replace Python with Java. So what it does, it changes wherever we have a Python word, it changes with Java. So you can see the output, it has replaced Python with Java. Secondly, there's a find function. It finds the occurrence of the word. So if we run find, it prints the first index or the index of the first occurrence. So let's say in this string we have Python 2 times appearing, but we want to find where it appeared first. So the find function helps you to find the index of the first occurrence. So in this case, this is at 7th index. The Python word is P is at 7th index. It starts at the 7th index. So that's why we have an output of 7. So if we count, so we can start from here 1, 2. A space is also we will start from 0, 0, 1, 2, 3, 4, 5, 6, and 7th index is the P. So that's why we see 7 here. Next we have count. This counts the occurrence of the characters or string. So in this case we had Python appearing 2 times in our string, so we have 2 as an output. Similarly, we have functions that helps us to find out or figure out some characters that are available. So for example, we have starts with and ends with. So whatever word that starts with rep uh, is available in our string, it will return true. If it's not available in our string, it will return false. So we had the string report.pdf, and we are searching if it starts with rep. Okay, and if it does, it returns true, and if it doesn't, it returns false. And also we are looking for something that ends with .pdf, and if it ends with .pdf, it returns true, else it returns false. So if I change slightly, we can see the false. Okay, two very important methods that are split and join. So we have the data that's comma separated in a string. So these are part of the string, and we want to split them on the basis of the delimiter or the correct or some certain character. So what we can do is we can just use the split method of the string, and what we get is a list. So we will discuss list in the next video, but when we run it, we can see that this splits this original strings into multiple strings, and those strings are stored in parts variable, which is a list. And if we print the original data, that appears like this as it is string. And if we print the parts variable which we received here, you can see we have a list of different words that were originally comma separated. Now they appear in form of a list. And if we see the type of the parts, it's a list type. All right. So next we have another 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 function that works on strings. So now we have something in a very that's different. So we originally have a string, a list containing multiple strings, and what we are going to do is we want to make a single string out of it. So this is a list in which we have multiple strings. We have 3 strings. Python is easy, and we want to join them. So what we can do is we can use inverted commas, shows the string, and we use the join keyword, and we pass the list into it. So what it does, it creates something like this. Okay, so Python is easy. So let's say if we replace the space with comma, so it will join everything that is in comma separated form. So if we place, let's say, endl, and now you can see every character that's stored in this string will be in this form. So it's a journal conversion of Python list to strings. Okay, that just converting the list of words in Python into string. Next we have uh, checking the content in the list. So we have multiple functions, that is alpha, is digit, and is alnum. So is alpha checks that if the current string has alphabets in it, and it returns true or false. So as of now you can see it has only characters, alphabets, and it returns true. So this one returns if the string has only digits, and in this case we had 1 2 3, it will return true. And in this we have a1, which is alphanumeric. It has both alphabets and numbers, and that's true as well. Okay, very interesting thing, that's alphanumeric doesn't work with space or special characters. So let's say in this we have a space 1, and it will return false because there's a space, and space doesn't like comes under alphanumeric. So if you run it without space, you can see it's true as well. So that's it for this video. In the next video we'll discuss a list and tuples. Thanks for watching. Bye. Hi, in this video we will be discussing about sets, a very important data structures in Python. So a set is an unordered collection of unique elements. So unordered means no fixed index. and unique means there cannot be any duplicates. So is it mutable or not? It's actually mutable. You can add and remove items in it. So it's what is used for. It is commonly used for removing duplicates and check the membership. Let's see if something belongs to a set or not. And it can also perform all the union, intersection, and difference set operations on any given collection. So how you create a set? Here is an example for it. What you do is you write elements in curly braces and you assign it to a variable, a name, and this makes it a set. So here is more elaborate example. Here we have variable nums in which we are assigning a list as of now, and now we are converting this list into set. So important point here is to look in the list and see there are duplicate elements. There is two times and three times. So what set does, it actually removes duplicates, and after that we are actually printing both of these lines and printing nums and unique nums. So this is a set and this will be a a list. So after printing these, we can see that the original list has multiple and duplicates, and when we convert it into set, this is with curly braces and without any duplicates. So there are a few methods in sets that can be used. One of the very few of the very popular are available right here. So one of them is add, remove, discard, and pop. So add actually adds an element, remove removes it. So discard is also similar to remove, but remove generates an error if you are trying to remove something that doesn't exist in your collection. But whereas discard doesn't cause any error. If you are trying to discard something that's not available in the collection, it will just move forward and leave it for that. Next is pop. So pop is also removes an element, but it removes an arbitrary element. So it can be any element that can be found in the set. Okay, so here is more elaborate example using these functions. So first we create a set. It has -1, 0, 1, 2, and 3. So there are no duplicates. So what we do is we add 4. We call the function add and we add 4 in it, and then we display it. So after adding, we can see that a 4 has been added in the list. Sets. So next we discard something that's not in the set. So we can see that there is no 10 in the set, and we have ran a function with the parameter 10 of discard. So this won't discard anything, and there would be no error. So the resultant set has nothing changed, and we haven't been able to discard 10. After that, we have our remove function. So what remove does is actually removes the particular element. So for example, in this list, we are going to remove 2, and as a result, we can see that 2 has been removed in the output. So if we enter anything that's not available in the set, this remove statement will cause an error. Next, we have pop. So pop removes an arbitrary element. So we can see that it removed 0 from this list, and that's the final answer. So for interview point of view, there are very few important questions that are related to set operations and how you can make a union out of two sets. What is the union? Union takes all common and unique elements of the sets and combine them together. What is intersection? It takes only common elements and makes a new set. So what's the difference? So it is about elements of A that are not in B. So for example, let's look at an example. If we try to union these, so common elements and unique elements will combine together. So union operator uses single line. So if we perform A union B, we will get 1, 2, 3, 4, 5, 6, and that's the output. Next, we have intersection. Intersection we can perform using and ampersand operation, and when we print it, we can see that only common elements between set A and B are printed here. So What are common? 3, 4, and that's what we have as an output. Next is difference. So set the like elements in A that are not in B. So we can clearly see 1 and 2 are not in B. So we can see 1 or 2 being printed. Next we have B minus A. So like we can see that 3 and 4 are not in A. So we will get, sorry, 5 and 6 are not in A. And we can clearly see that 5 and 6 have been printed. So that's it for this video. We will see what are dictionaries, a very important data structure, in the next video. Thanks for now. Bye. Hello. Today we'll be discussing a very important topic in Python, that is list and tuples. So list and tuples are very, very important data structures that are built in Python. So Python traditionally has no arrays. So it has built-in data structures like lists and tuples. So what is a list? It's an ordered mutable collection. And what is meant by ordered? Ordered means items have positions and indexes. So you can access a particular item in a particular index. And mutable means that like you can change it. So for example, we have an example here for a list. You have 10, 20, and 30 as its elements, and you can change any index or add anything to it or remove from it. So this is what mutable means. So arrays, the list in Python are mutable. So the next data structure that we are going to discuss is tuples. Tuples are also ordered, but they are immutable. So here is an example, like right now. You can see we have a point variable in which we are assigning 10 and 20. These variables have access to the indexes, but they are not able to change it. So we cannot add anything new it, we cannot remove it, or we cannot like change any index. So it's a very important interview question. So like what's the difference between mutable and mutable types? And so also you have to tell when you don't want to change something, you use tuples, and if you want to change something, you use lists. Here's an example. So we have created a variable and nums list, and we have assigned a list to it. List contains 4 elements, 10, 20, 30, and 40. We also created a tuple, and we are assigning 10 and 20 values to it. So just printing them like this prints them, and we're also showing their types by using type function. And what it does, it displays the type of that particular variable. So we can see the complete output. We have a complete list as an output, and it also displays the data type of that variable. And same goes for the tuple. Okay, and next we have another example which applies slicing to the list. So we have a list having values 10, 20, 30, 40, 50, and 60. So if we enter 0 index, this will print 10, you can see as below. And if we enter -1, as we know that when we start entering the indexes in negative values, we start from the end. So in this case, -1 represents 60, the last value, and we can see 60 has been printed. Now we are giving a range 1 to 4. It will display all the elements from 1 to 3. So this is the index 1, 2, and 3. So you can see we have printed 20, 30, and 40 here. Finally, what we did, we missed the start and the ending values, and we gave -1 as step size. So what it does, it prints the whole list in reverse, and that's what we have received here. So there are many common list methods. One of them is append, insert, remove, pop, sort, and reverse. So important point here is to append, we can append any element. So it can be a variable or a different data type. We can also append list in list, and we can also insert at a specific index, and we can remove an element. Okay, and it removes the first occurrence. Pop actually removes the last element, and sort actually sorts them in place, and reverse actually reverses everything in the list. So let's see these functions in action. So we have a list of strings in which we have apple, banana, and mango. What we did here, we have a list named items. We appended orange, and we printed it after the append. So we will get output as like this. Next, what we did, we entered the index 1 and we entered grapes there. So you can see that previously the list looked like something like this, and after entering grapes at index 1, the list has another element into it, and the resultant list looks like this. Next is pop, and what it does, it pops the last element out of the list, and you can see that we can see the popped element and the complete list afterwards. So we can see that we popped orange and it was the last element, and similarly we when we see the list, it has no orange in it. Similarly, we have a remove function. If we remove banana, it removes the first occurrence. So we remove the first occurrence, and what we get is this list. Finally, we can sort numbers. So we have a list of numbers. It has 5, 2, 9, 1. They are not in any order. What we do, we call the sort function, and it gives us the number in sorted order. And that's what we are receiving here. And if we use the reverse function, what it does, it reverses everything in the list. And that's what we have received here. So list versus tuple mutability, what is meant by that? So if we have a list, and what we do is we enter or replace or update a specific index, it is doable, and we have done it like multiple times in the previous examples as well. So that this proves that we can change, mutate, or modify our list. And for tuples, that's not possible. We cannot do it, because if we modify this, if we try to modify this, we always get an error. So let's say if we try to run this, this would say that this is not possible, and we cannot do this, and it will raise a type error. You can see that. So in tuples, we cannot modify anything. Okay, so that's regarding the mutability of tuples and lists. So here are very important concepts that are commonly used, and they're very much asked in interviews. That is packing and unpacking. So if we like write variables in comma separated and try to assign to a single variable, it creates a tuple, and that process is called as packing. And similarly, if we have a tuple and we want it to be in its values in different variables, so we can write like variables on the left side and the complete tuple on the right side. And what it does, it assigns values to those variables. In this case, we had variables 1, 2, 3. Like tuple had 1, 2, 3, and ABC will have 1, B will have 2, and C will have 3. And this is very interesting, because this is again a very important interview-based question, which is normally asked. What is Pythonic swapping? And this is exactly where the packing and unpacking is being used. Here we can see a tuple is being created and it's unpacked here, and swapping is done for two variables in a single line. All right, so here we have that example. We can see the output. So we had we created a tuple with different with 1, 2, 3, and then we unpacked it. And after unpacking it, we displayed the t and the values separately, and that's what we get here. And finally, we did the Pythonic swapping, and that's what we get. So that's it for this lesson. We will work on sets, dictionaries in the next video. See you then. Bye for now. Hi, in this video, we will discuss the dictionaries, a very important data structure in Python. So it will take 5 minutes, and we will be able to understand how dictionaries work in Python. So dictionaries are actually data structures that store key value pairs. So like the one we can see in JSON. Actually, keys can be anything like string, int, tuple, etc., and they have to be unique and hashable. So for the values can be anything, and it's a very common way to like name keys with strings, and value can be anything. So how to create a dictionary? We have an example right here. So what we have is curly brackets, braces, and in these curly braces we have a key name with inverted commas, and then we have a colon, and for that key we have a value that's here, and again we have a key age, and for that we have a colon and a value here. So a very important interview question is generally asked. So what is the difference between list and a dictionary? So you can say that ordered, it's a collection item that's mutable for the list, and for the dictionary, it's a key value pair, and it's a very important data structure for looking up fast. Like it's used for fast lookup and create key value pair elements. So here is a proper example with the student like name, age, and is active. These are actually keys, and we have their corresponding values. So it's written a bit differently, and they're separated by commas. Most importantly, and they're written bit differently in each line. So we can also do that to make it more readable. And then we did, we printed it, and next line we actually print the type of that variable. So we can see that the way it's written, it's exactly prints like that, and we can see the class here, and the type here is class dictionary. So how we can access values, like how we can change, update, or access values. So again, uh, a dictionary in which we have a name, age, and what we have here is like we are trying to print name. So what we did, we write the name of the dictionary, and in square brackets we wrote the key, and as a result we will see the value of that key. Next we have age. We are going to update that age. So currently we have 20. How we can update it? We could write the name of dictionary and write the key which we want to update. Here we wanted to update the age. That's 21 now, and now we print it. We can see the updated age here right now. So here we can see the age has been updated to 21. Next we have next actually we can see that there is no city key available in the student, and this is the way we can add a new key value to current dictionary. So what you did, you wrote student city, this is a new key, and we wrote the name in it, and once we print it we can clearly see that a new key value pair has been added, and that's a way we can add more key value pairs in a dictionary that's already been created. So there is a way to save accesses. Okay, something that's not available. So we can see that the name is something that's available, and how we do it, instead of directly accessing it with square brackets and writing the name of the key, we can ask to get it, like dictionary and get function, and the key that we want the value of. If we get the key, we can like print or get the value, and if it's not available, we can print some default statement like not available. Okay, the common dictionary elements, like common dictionary methods, are keys, values, and items. So we have, if we like only take keys and then convert it into list, we can clearly see that we have only list of all the keys in the dictionary. We have also a function for values, which response can be converted to list, and we can see all the list of values in that particular dictionary. Finally, items, what it does, it returns the complete dictionary as a list of tuples. So each key value pair is like placed as tuple in a list, and this can be easily be iterated using for loop, the for in loop. Oh, okay. Here is a complex example. Here we have nested dictionaries, and more realistic and real world example. So in this example, we have main three keys and their values, and we have nested key value pairs as well. So we can see that we have first key, that is username, and that's separated by another key, that's profile, which contains another dictionary. So the value for profile is another dictionary containing full name and email as the key value pair in it. And finally, we have a status, and status is also a key for user, and inside the status value we have another dictionary, and that dictionary contains some values. So how we can print it? We can use like username. This will exactly print this. And if we try to print username and profile, it will print this. But if we want anything specific from it, for example, like full name, we have to further specify that in this dictionary we want full name. Otherwise, we will display this complete dictionary in it. Same goes for stats. You can like specify which we want with post or forward, and that's how we can print it here right now. So that's it for the video for practice example for sets, list, dictionary, and tuples. We will have a next video. Thank you for watching. See you then. So in this video, we will be discussing some practice questions that will be based on strings, lists, tuples, and sets and dictionaries. So let's go to the first practice question for strings. In this example, we have been asked to take a string as an input and print first three characters, last three characters, and string reversed. So like we have like taken an input here, and we can see that the input, the prompt is asking for entering a string, and we have like printed value. That's the value that we're like receiving the input in, whatever the value we get. And once we get the value, we can see that we have mentioned string slice, that we want to start with 0 index and print up till 3. For example, if we can print if we can like input Python, you can clearly see that we can like using this we can print first three characters of the word, and for the last three characters we can start at the end, like discussed in the previous string lecture. For the Python, we discussed there are negative indices as well in Python, so we started with the third last element in the word, and we then moved forward till the end, and that's where we were able to print HN. For reverse, we can like start like from anywhere from 0, or we cannot mention anything, and we can just mention the step size, that's -1. That will print everything in reverse, and we can clearly see it here. Next we had an example like practice question in which we were asked to count how many times the word Python appears, and it should be case sensitive. So we can see that we have a sentence, and we are actually inputting in the sentence variable, and what we will do, we will count the number of Python appearing that sentence. So we can write that, we can write something like Python and like space again Python, and we can write something like with lowercase Python, and let's write Java as well. So I've written like 4 words, and let's see the count of Python, how many times it is appearing. It's actually 2. Why it's 2? Because even though we have written 3 times Python, but we can clearly see there's a case that's not matching. So we are searching for an uppercase P, YTHON, and this is a lowercase p. So that's why we have 2 answers here. Let's look at the third question. That is from list and tuples. So it's asking to take 5 numbers from the user and store them in a list, and then print the list. And for the next task, we need to find maximum and minimum using maximum function in the list. So it's a very easy question. We can clearly see that we created an empty list, and we created a for loop with range 5. What it will do, it will take input, and we are appending the value that we are inputting. And very important thing, we are converting that input to int. So we have typecasting it as well. Once we have a complete list that we wanted, now we can print it. And for the max function, we can just pass the list. It will give you the max value. And for the min, it will give the min value. For example, let's say we enter 1, 2, 3, 4, and 5. We can clearly see that we have max value 5 and min value 1. Let's look at the question number 4. So here where we have to create tuple, and we have to create a tuple containing your name, age, city, and print using unpacking. So having said that, we can clearly see that we created a tuple and in which we pass the name, age, and the city. And that's actually the part of packing where we are creating uh, a tuple and assigning to a variable. And that's the part where is unpacking. We are actually unpacking the tuple and assigning the variables their respective values using unpacking a tuple. And we can clearly see, we can print them and clearly see what the output is. So we unpacked it successfully and we can see the output. Next, we have fifth question that is from sets. So it's asking for taking 6 number from the user and store them in a list and convert them into a set and print a unique number. So we know that like converting anything to set, like any list to set, will give us unique numbers or unique elements. So here we again created a loop. Now this time the loop is for 6 values, and what we are doing here is we are appending the values to the list. Once we append it, here is a statement that converts that list into set, and it removes any duplicate elements. Now we get unique elements and we can print the complete set here. So running it, and let's input some values: 1, 2, 3, 4, 5, and 6. So yeah, let's run it again and let's enter some duplicate values. So I can add 1 times, 2 times, and 3 times. Okay, so we get 1, 2, 3 because 2 and 3 were repeated. So that's the answer for practice question number 5. Finally, we have our last question for dictionaries. So that's asking for creating a dictionary for student name, roll number, marks, and put it in a cream format using string. So yeah, that's a very interesting question. That also uses string. So here is the dictionary that contains name, and we have written the name. We have entered the roll number. We have entered the roll number, and then we have marks, and we entered marks. And finally, we are printing it. We are printing it using the f string. So f string is a string which allows you to use variables in it, and we can print them as is. So here's a very interesting thing. We never separated the inverted commas. So it's a single quotation, and in which we have introduced curly brackets and we have written the variable to print. So it will print the value, not this as is. So that's the power of a string that can be used to print the values. So that's it for the practice questions. You can try it yourself, and we will see you in the next video. Thank you. In this video, we will be discussing about the scope of the function. So we can have different kinds of variables in a function. Variables can be local or global. Local variables are the variables that are created inside the function. They are used inside the function, and they cannot be accessed outside the function. So those are local variables. What are global variables? That are created outside the function. Multiple functions can use that variable, and that variable can be accessed by other functions as well. But there is a very important rule which Python follows whenever it's going to look up for a name. So first it looks up for the local variable, sees if there is a variable that's inside a function. Second, it goes for the enclosing, the variables that are inside the function, nested function concept. And then it goes for the global variables. And finally, it looks for the built-in variables and variables in the Python. So here is an example which follows a local variable. The x is created, value 10 is assigned, And what we are doing, we are calling this function, and the variable x is created here, displayed here, and it ends here. So after it's done, if we try to print it outside the function, it will have no value. It will give it actually an error, and the error will be name error because x is not available in the global scope. Next, we have created a global variable g, that we are trying to access in a function called read global. Here we can easily print it and we can see the value. We can also print this function outside the function, this variable outside the function, and we can see the value of g here, and that's printed 100. So another example is that changing global variable inside a function. So that requires very extreme care. So in order to modify it, we have to use a global keyword. In this way, we can ensure that the global variable is being updated, not a local variable has been created. So it's generally like it's in a professional code. Have a use of global is not very encouraged. It is actually very important to make it make least amount of use of global keyword, and it makes it very hard to debug codes. So here we have a counter variable and there's an increment function. In this function, we want to use this global variable, so we write global counter, which refers that this is not a local variable for increment function. This is a global variable, and we are going to use it here. And here we are incrementing one in it, and we are actually calling the function increment twice and then printing the value of counter. So you can see that one will be added twice in the counter, and now we have two as an output. So a safer alternative is not to use global. Instead, assign the value to the global variable. So instead of like writing, like in the previous example, we saw that we used a global keyword. Instead of doing that, we can create a local variable here, increment it, then return it, then assign to that global variable. So it's a much better choice and a safer choice for assigning the value. That's it for the lecture. In the next lecture, we will discuss more in detail about arguments and keyword arguments. That's it for now. See you in the next video. Bye. So in this video, we will be discussing about functions in Python. So what is a function? So function is a way of writing code that helps us to make it clean, reusable, understandable, and it helps us to make our work manageable. So function, like it's a piece of code that's written separately, and when called perform a specific task, and it allows us to reuse it again and again without writing it multiple times. So we write it once and we can call it as many times as possible. So here's a basic function in Python. So what do? We write def, the function name, the brackets, it generally contains the parameter, and the code block. Remember, the Python function has no brackets, it works with indentation. So we have to place some spaces for the compiler to recognize that this is part of the block. So why functions are important? It offers reusability, readability, extra testing, and helps you think small logical parts, which helps us to better understand or better resolve a problem. We have a very basic function in which we are printing a statement. So def is important. That tells us that we are creating a function. That's a function name. We have a bracket, and after bracket we have a colon. And in the next line, we have given a space, a tab, and after that, we have written a print statement that says, hello, welcome to Python. And after that, we have called this function two times. So what will happen is the interpreter of Python will come to this line and execute this function once and then again. So having done that, we will see print these statement printed twice. So let's run it and see how it works. Yeah, we can see that it has been printed twice. So it is very important to name a function very carefully. We should name it always with meaningfulness, and meaningful names help us to create functions that make sense while debugging or updating the code. So next we can see how function works with parameters and return value. So parameters are like inputs to the function. We can provide it when we are calling it. So for example, here is an example in which we are creating a function add, and we have two parameters a and b, and what we are doing, we are passing values to it. So here is how we can pass the arguments to the parameters. What's a return statement? So there are like two approaches. So here's an example in which we are doing something in function, we are printing it here, and sometimes we don't want the function's result here. We want it back from where it was called. So for that reason, we need return statement. So whatever we have done in the function, we want it back, we can use the return statement. Here's an example of a function. The function is add. So what we are doing, we are passing two parameters a and b, and next we are printing all the value, or like the sum of these both values, and that's a print statement. So how are we calling it? First we call with 5 and 7. So what happens, 5 gets copied or like saved in variable a, and 7 gets saved in variable b. We sum them together and we get 12. Next we call the function again with 100 and 250. So 100 will be saved in variable a, and 250 will be saved in variable b, and then we run it, we'll get the answer 350. So that's the point, that we are actually printing the value or printing the answer in the function. Just in case we want the value or the work we have done in the function back from where we called from, we have to use the return statement. So this function says add underscore return, which is just a name that signifies that we are going to return something from it. What we did, we summed a and b and returned the results. So now when we call the function, we send 5 and 7. So 5 is copied or stored in a, and 7 is stored in b. We sum them together, and the answer of this sum is returned. And once this is returned, it returns back, and we are saving it to a variable named result. And after that, we can print it right here, and that's the answer we are getting here. Okay, so yeah, we discussed that the print is very important when we want to print something, and we do not want the result back from where we called. And generally, return is used to get the value stored or reused or tested. So it's a very good idea to use return statement instead of print. So it's a professional way to do it. So here's another example in which both print and return statements are being used. In this example, we are finding the area in which we are receiving two parameters, length and width, and this is a function that prints the area by just multiplying length and width, and that's it. In the second function, it's our area with return. So what it's doing, it's multiplying and returning the value. It's also saving same those parameters as this one. So now we call the area print. We pass it 10 and 5. We get the product of 10 and 5, which is 50, and area 50 is displayed in this function right here. Next is the function that returns. So in this we have called the function with 10 and 5, and we are storing that in a variable a, and after that we are printing that variable a. So one very important thing about the parameters, we can also have a default parameter. So for example, here's an example. So we have a function in which we have already assigned value to that parameter. So this default value means that if a user passes the value, this will be updated, this will be overridden. But if it's not sent by the user, so the function will use the value that's being assigned default to that parameter. So for example, in this case, we are sending a value, and what happens is this values get updated, and the name gets printed, and you can clearly see the output right here. And in case we don't send it any parameters, we say like just run it. So in that case, this will have no value, like updated value. It will have the default value, and it will print exactly that. So that's it. Next, we will discuss how we can use keyword arguments and args. So stay tuned for the next video. Thank you. Bye. we have a very important concept in Python, that's decorator. What is a decorator? Decorator is a function that adds functionality to the behavior without changing the original function code. Think of it as a gift. So you are not opening the gift, you are adding some wrapper to it to make it more presentable, make it more work. So here is key parts of the decorator. So first we need a function that we need to add functionality to. For this example, we will take origin function. Origin function is just printing hello. And now we are going to make a decorator function. So decorator function looks like this. It's a function that wraps your original function. So it is named myDec. You can name it anything. For this example, we have named it myDec, and there is a wrapper function in it. So there's the concept of inner function in Python, that we can create a function inside a function. So we have created it, and in this function, you see we are calling the original function. So we will receive a function here and we will call it. And after that, we are returning the inner function. So let's look at the example, how we can use it now. So here's an example. One way is to write the decorator name at the top of the function. This way, you will automatically make it work with the decorator. You will add functionality that decorator provides to this function. Secondly, you can do it manually. How you can do it manually? You can call the myDec and pass your function into it. So these are the two ways you can use it. How the execution works? If you write myDec like this on your function, or you can call it directly. It returns a wrapper function, and when it returns the wrapper function, it actually runs whatever is in the wrapper, then the origin function. And like for our example, we can see that we have before function, we have the actual function, origin function, that will be executed, and finally we have the after function. So this will be the execution of these functions. We can also pass decorated arguments, and here we have an example that we have received an argument in the wrapper function, and we pass it to the origin function as well. In summary, we can say that it is like origin function is your main function, decorator is wrapping around your function, and wrapper is the actual function, inner function, that is providing you functionality or adding your functionality to your original function. We can use @decorator for shortcut, or otherwise we can call the function directly using the decorator. For the usage, where we use decorator function, it's generally used for logging, permission, timing, and debugging. So we generally print messages, we can check login permissions, we can add functionality to the original function. So that's the use of a decorator function. Next lecture, we will discuss about the fixed data types in parameter. Bye for now, see you then. In this video, we will be discussing about arguments and keyword arguments. So sometimes we don't know how much of arguments we are going to send, and how much values we are going to send. So in that case, we can like pass args to it. So it's a variable length argument. So it can have it actually is a tuple, like the value we send here becomes a tuple. And how we can write it? We can write it as static and args, and the Python automatically understands we are expecting more than one value, or multiple values, like one or more, or zero or more values. And what happens is that whatever we send comes here and becomes a tuple. Similarly, we have keyword arguments. In this, whatever we send from the function call, it actually becomes a dictionary here, and we have key value pairs that are here and which we can use. Okay, here is a very good example how we can use args. So we have made a function add many. We have declared an args variable that is with asterisk, and we have a total variable, and there is a for loop that iterates over the parameters that we have received. And what happens is that we sum all of the values in the parameters and we return the total. So if we come to main, we can see that we are sending add many 1 2 3 as parameter. So 1 2 3 will come here, and it will be all summed up into the total function, and numbers will be iterated. Actually, numbers will be containing 1 2 3, and we will have a total, and that can be returned. And what we can print, and we can see the output. That's 6. In the next statement, we have multiple values 10, 20, 30, 40, and 50, which are being sent to this function, and we can iterate over them similarly to get an answer of 150. Next, we have keyword arguments. Here's an example. We have a function named print profile. In this, we are receiving keyword arguments. And what we are doing here is we are iterating over it, as we have like discussed before. If we do items, we get the list of tuples, and those tuples contains key and value, and that can be uh, we discussed the concept of unpacking, which can be unpacked, and after unpacking we can display them as key values. So what we did, we created some some key value pairs. What we did, we gave name and we assigned value to it. We gave age and we assigned value to it. Similarly, we did city and we assigned a value to it. So this whole went as a dictionary, and when we received that dictionary, what we did, we convert it into items, which is actually list of tuples of key value pair, and then we iterated over them and printed them one by one. That's the output here. Okay, we can also use args, static args, and static keywords together. So you can combine them both in a function, but there's like a specific rule. So how you can combine them? There's an order we have to maintain. So if we have like a normal parameter that has to come first, like the title here, then we have to place static args, then keyword only parameters. So that's optional, and then we can have static keyword args. So we can have them in this sequence. So here's an example. You can see here we have created a dictionary. Actually, we have created some values. So in this first value, we have given just a string. In next value, you can see we have mentioned a few values that are like the values that will come into args. And next we have some keyword arguments that are in the form of key value pair. So what this portion will come here, and this portion will be stored in this as a form of tuple, and this will be stored in title as a string. So what we do, we print them one by one, and you can clearly see that the first came as a string, and which is stored here. Second came as a tuple, and you can see there is a 10 20 30 tuple, and finally the keyword arguments came and they are printed as the dictionary. So in other words, we can also unpack it. How we can unpack it? So here's like what we use generally. So we can for example, this is a list, and what we did, we called add many. That's a function that we created up here, and what it does is it's like adds them and returns the answer, and that's what we received here. We sent 1 2 3, and it took the list as is and performed the task. Secondly, as keyword arguments, we, instead of like providing it, we gave it a dictionary, and that's what it received. This function show data, and it's print profile. That's actually here, and it printed everything in this dictionary. That's it for now. We will discuss lambda functions in next lesson. So see you then. Bye for now. Why would you do that? This is very important because it is used in some specific functions like sorted, map, and later topics that we will discuss. Here is an example of a normal function that we write in Python. There is a def keyword. We are squaring we are receiving a parameter and we are multiplying it with itself and returning the value. Here is a lambda function that does exactly the same. There is no name and there is no two-line function. So we have written lambda, that's a keyword. We have written x as a parameter and we are multiplying itself and this value will be returned. We are storing that lambda function in square variable, and whenever we call it with 5, what it does, it returns the square and we can see the square value printed down here. There's another function, add function, we created using lambda statement, and there we have two parameters a and b, and we are summing them up and returning the value. So you can see when we pass 10 and 20 into it, it sums up and returns a value of 30, and we can see the value 30 here. Okay, so why we use def and why we use lambda? Lambda is used where we need smaller functions, single statement, single line functions. It is very efficient to write the code this way. Here we have a student dictionary containing student name and student marks. And here we are using a sorted function, which is traditionally not used to sort dictionaries. But we can use it using a lambda function. We can use key s colon s marks. What this does, this sorts the student dictionary based on the marks values. And there is a reverse. This sorts it in the descending order, and we have printed finally the dictionary, and we have this answer. That's it for the video. Next video we'll be discussing decorator functions. Bye for now. Hi, this is a video in which we will discuss how you can fix data types in a function. So function can only accept a specific type of parameter, not any other. So a clear way to understand is with this example. So we have a function, we have add numbers, and in this we have two parameters that we have passed, and we have written what data types they should be. For this example, we have written int for a and int for b, and there's an all type that's written at the end. That's int type that tells us what type of data you can return from this function. So practically writing the values with data types, you can easily fix what type of functions, what type of parameters should pass. So why would you use it? For code clarity, error detection, and better documentation. So here's an example we can use it. So we have passed 5 and 10 to the function that we have created, and it works. And if you pass any other thing, it won't work. It gives you a type error. So one important thing in functions is that we can write a docstring. You can use triple quotes to write the docstring. So whenever you want to see what is in your function, you can just print it using double underscore doc, double underscore. Before that, you can write the function name with the dot. So you can see it returns everything about the function that's written in the docstring. That's it for the video. Thank you. Next video, we'll be discussing nested Python functions.